All right, so this is going to be called, I don't know what else to call it. I call it vibe check. Basically, the idea is, how positive is the statement being made? You saved some good repos? Oh, nice. Good to hear. All right. What do we want to do here? So let's see the plan. Okay, so the plan. So let's define the architecture and the plan, right? So we'll have architecture. It's really simple. I think this is really simple. I think it's very possible that this will work very nicely. We have the Gemma. Was it called Gemma Embed? I had it up here. Where is it? Did I close it? I hope not. I can just find it again if I did. Oh, no, I didn't. Okay, here it is. Called Gemma Embedding 300 million. All right, use this, which we also used when we were building that trade bot. Building a prompt evaluator. Oh, very nice. An optimizer with Pydantic AI agent graphs, Streamlit, and MCP servers. You're putting everything together so cute. That's great. Comparing the different LLMs and prompts, making them deterministic. Very nice. I like that idea. That's great. You found every possible word. What else? What are you missing? You're missing LangChain, maybe? Are you using LangChain? What else could you add in there? You have some Similarity, some vector databases, some RAG, retrieval augmented generation. You almost got every keyword. All right, so we got text input. All right, Gemma embed. Let me get our vectors. Vectors. All right, text input. And Gemma embedding. We get our vectors, and then we need a baseline. So we need to capture the baseline. All right, so we got happy, joy, awesome, like good words, right? Then we get the baseline, and then let's see here, like that. Haha, yes, but my Pydantic is better than LangChain. Oh, really? Okay, in your opinion, because you can force the LLM to output objects back to you. That does sound like it's a lot nicer. That does sound like it's an improvement because you have more control. It sounds like if you're saying the objects directly rather than. So we use this used for distance comparison. All right. And then text input, right? Could be bad, could be good. Then we get our vectors out. And then we take our vectors, subtract them, or get a dot product or something. We do a comparison with the baseline. Equals some value. I don't know what this value is going to be. We will be able to find it out, and then we'll be able to compare it with our baseline joy, happy, awesome, like positivity, and then see what the difference is. And then we should be able to paint a range. And so I need a dictionary of, we need some data sets. We need data sets here. Data sets. We need a positive words, and then, or positive phrases, I guess, right? Phrases. And we got negative phrases. Now that we've got sort of our data sets, we've got positive phrases, negative phrases, we've got our model. Let's look, and it's really simple. Like, this is gonna be the algorithm right here. I think this should be fine. I think we're good to go. Count quality assurance. That's exactly quality assurance. It's gonna be, obviously you could use NLP for this. One of the bonuses of using the Gemma embedding. So we said why Gemma embedding, because it's multilingual, which allows us to write everything in English, and it should work perfectly. So that's it. I don't think we have to go any further on this. This is really simple. We can immediately get started on this. So let's copy this code here. All right, let's get into our. All right, so I do believe I already pip. Right, someone was talking about UV. I'm actually our requirements. Are we good to go? Yeah, looks like we're good to go. All right, vi main.py. Okay, let's set paste. Not patch. Paste. There we go. Okay. Set no paste. Okay, so we're grabbing a sentence transformer, grabbing it's just gonna be embeddings, and we're gonna go and we're gonna print it. Let's see if this actually works. XHQ printed shows similarity values between embeddings. Is that what I did? All right, so, let me see here. I want similarities. Oh, yeah, you're right. I just copy and paste it here. Okay, so I want the embeddings, not similarities. Return dot product instead of normalized cosine similarities, or the embeddings weren't normalized first. Yeah, your shape output would be 14.4 is unusually similarity matrix normal. Yeah, all right, thank you. I should have been paying attention. I would have figured it out eventually. I'm reading chat though, you guys. I'm reading chat. Comparing 14 vectors with themselves gives a 14 by 14 matrix. To fix it, normalize the embeddings and use the matrix multiplication to get the proper cosine similarity. This is our baseline input. Our baseline output. So embeddings baseline will be embeddings 0. I think that's the idea. And then we need our so this will get us the initialization. Bomb occult. Wait, what are you doing? Oh, bomb occult. I don't know. What is that word? I've never heard that word before. I don't know if that's a positive word. So we're getting a baseline input for our positive words to be used as our baseline when testing input from users. I was saying for the multilingual. Ah, yes, got it, for multilingual. That's one of the reasons why we're doing it this way. Okay. All right, let's see if this runs. I want to make sure it runs. Okay. How's it going there, Shrikanth? Shrikanth, welcome on in. Good to have you here. Oh, sentence isn't defined because I deleted it. Baseline input. All right, so let's try that again. Okay. Shrikanth, welcome on in. Good to have you here. Happy Wednesday. I think he's referring to the subtitles. Yeah, me too. I think so too, right? Look at subtitles. Hey, oh, look at that. 100%. That's exactly what we're looking for. We're looking for 100%. There we go. So now that we've got this, we can define our functions. Okay, so we need to set up. We need to start up. Start up. Def. Start up. Okay. We want our baseline. All right, we need bad. You did badly. There we go. Let's see if that works, right? And I want to print. So this will be bad. This will be good. All right, good. All right, you did good. Good job. All right. I also wonder if it'll work with emojis. Do you think it'll work with emojis too? Let's find out as well. Emoji. We'll do this. Party popper. Emoji. Party popper. See if that works. All right. I don't even know if this code's going to work. We're going to find out. Okay. Let's run it here. All right. Let's see if it works. I'm kind of curious about this. This has been an idea that I've had for a year or so. Okay, so we got a problem, but I'll read it through later. Oh, it didn't do what I thought it was going to do. Oh, it's not working. The similarity. Oh, I know why. I didn't. You did it, Steven. You did it wrong. I'm like, oh, okay. So we got to do this. That's why it was 1. I was like, why didn't it work? Oh, that's why. That's why it didn't work. Do we need it to be? Where is that embedding? And am I even using this? Yeah, I'm using it right there. Today, Quantum is doing taxes. Oh, hey, Quantum. Good to see you, Quantify Quantum. I'm like reading your own message there. Taxes is the time. Taxes, you guys. It is tax season. I don't want to. All right, embedding. Where is this? Here, embedding positivity. Do I need it to be? I forgot. Here, let me go. So this is the embedding right here. A lot of words here. All right. And then a tensor. Okay. All right. Let's find out. I think we may not need that. I'm just double checking. I think so. I think that might be it. So we'll run it again if it fails. We'll find out. Here are my 2 Discord servers. Cool. What? Did it work? Oh, it worked. Oh, look at that. All right, perfect. The emoji is the most positive thing of them all. Look at that. Words in a different language to see if it still works. That's going to be the ultimate test. What I want to do is, let's see here. Let's do emoji sad face. We'll do a sad. Or ing, sad. All right, I think very sad. Oh wait, that won't work. Let's see. Is there sad? There's another sad. How about this one? There we go. Perfect. All right. Let's see if that works. Vibe sad, and then first encode your baseline text in a new sentence using a model.encode. Then use a proper similarity function like cosine similarity to get float between -1 and +1. Oh yeah, that could work. We could do that too. So we've got our embedding output, and instead of this, we could do something different. So right here is what you're saying. We could do something different. We can import torch. So import torch, and then you said I'll say tch sim, or maybe cosine sim equals torch. What'd you say? Dot nn dot functional dot cosine similarity. Did I do that right? Copy paste that there. All right, we'll see if that works. Torch functional cosine similarity. Wait, one argument must be a tensor. Oh, got it. All right, so torch dot, was it tensor? Wait, I forgot how to do that. ~/desktop. Desktop. Was it Python basics? And then we've got a folder here. Torch guide, main, torch. Where is the array at? Here we go. Tensor. All right, so it was tensor. Okay. Tensor. And then that was it embedding or was it this? Which one was it? Was it? Oh, right. Okay. Okay, I think that'd be better. Okay, so we do that. Does this give us, is that still a tensor? Is this still a tensor? We're going to find out. Okay. Otherwise, we'll have to convert it. We'll convert it. How's it going there, Tanjiro? Good to see you. Welcome on in. Must be a tensor. Okay, so the first argument is an NumPy array, which is embedding right here. Encoding is returning. It's returning a. So I need to convert that back over to 10. Let's see that. That's the trick. This is the ultimate test. Oh wait. Oh, did I get rid of torch? All right. Now we're really testing it. Yep, that counts. That did it. We figured it out. Look at that right there. Oh, I'm very happy now. All right. I essentially solved the riddle. I solved the riddle. I did it. So you can see with the vibe check, how close is it to positive? How close is it to negative? We just used the Gemma embedding model. Just the embedding. We're not using an NLP or anything like that. And then we're just detecting the similarity between them in terms of how close they are. And check it out right there. Right here. They're very, 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 very close, right? Very, very close. 25% versus 30%. GG, we did it! What do you create your script? Alex, good question. So we just did, the idea is I wanted to use an embedding model that was multilingual, the Gemma embedding model, 300 million parameters, to get a baseline sentence and compare it to a sentence that is like of negative sentiment in another language. Which we did right here. So you can see right here on the screen, another language right there. And it worked, you guys, it worked. It's so great. I'm very happy about that. Very satisfied. I'm very satisfied.